Hello and welcome. My name is Sunshine Amos, the CEO and Project Manager, Sunshine Resources. In this video, I'm going to show you some mathematics associated with soap production, or generally in the manufacturing of household product. This video will attempt to show you how to calculate your soap recipe, especially the amount of ingredient and water required to produce standard quality soap. And so if you're new to this channel, I suggest you hit the subscription button so that you get posted of all our videos and resources each time we upload them. Now, mathematics is a language expressed with numbers, and virtually every day in life we speak the language of numbers as we add, we divide, we subtract, and even multiply. All these are done with number digit. It's important to note that in everything we do in life, there is a mathematics form of it. And so, just like I said earlier, in this video, we will be learning the mathematics of soap production. In soap production, for example, it is important that you know how to calculate the exact quantities of materials or chemicals required to produce certain volume or quantities of soap. Now, if you don't do this, you will end up with bad quality product, and that will amount to waste of resources. So, understanding the mathematics of soap production is a paramount skill you must acquire if you really want to be a soap producer. I'm aware that there are people who generally don't like doing mathematics. Even as a mathematics teacher, with my experience, I know quite a number of students don't have interest in mathematics. Now, this is a time you will need some element of mathematics to be able to move forward in life. Unfortunately, in the classroom, most of us don't even know why we are doing the mathematics, and that is why we have the cause to reject them. But now, in soap manufacturing, you need certain amount of mathematics to be able to do well in soap production. So just like I said, understanding mathematics of soap production is paramount skill you must acquire if you really want to be a soap producer. Now I'm going to point out the mathematics topics that are directly related to soap production. Now these are: number 1, ratio, and number 2 is variations. Now for those that have studied mathematics in secondary school, you must have come across the topic ratio and variations. The two of them are interrelated. As I proceed, I'm going to show you how these two topics in mathematics are interrelated. Now, ratio is used to compare quantities. Now, take for example, in the production of 15 liters of liquid soap, you will require the following item. You can see them on your screen now. Let's pay attention to the quantity of materials we have on the screen right now. Now, if you want to produce 15 liters of liquid soap, you will need nitrosol 50 gram, caustic soda 40 gram, soda ash 200 gram, STPP 60 gram, SLS 50 gram, sulfonic acid half a liter, foaming booster half a liter, color 20 gram, perfume 30 ml, preservative a tablespoon, and water 15 liters. Just like I said earlier, in this preparation, we're going to be preparing about 15 liters of liquid soap. 15 liters. Now, to produce 15 liters, we need all these items in these quantities that I've stipulated on the screen right now. For example, let me just pick the first two of them, which is nitrosol 50 gram and caustic soda 40 gram. Let me pick just two of the ingredients, that is nitrosol and caustic soda. Nitrosol and caustic soda. Okay, now nitrosol we need 50 gram and caustic soda we need 40 gram to be able to produce 15 liters of liquid soap. Point of emphasis: 15 liters of liquid soap. I will repeat it again. Nitrosol will take 50 gram, caustic soda is 40 gram to be able to produce 15 liters of liquid soap. Now, in comparing these two quantities, it can be written as 15 ratio 50. 15 ratio 50. This means that to produce 15 liters of liquid soap, we will need 50 grams of nitrosol. So if we want to compare them in ratio form, we will write 15 ratio 50. This means for every 15 liters of liquid soap that will be produced, we will need 50 grams of nitrosol, and it is written 15 ratio 50. Now let's suppose we want to produce 100 liters of liquid soap. Take note, suppose we want to produce 100 liters of liquid soap. You will agree with me that since the quantities of liquid soap we want to produce has increased, it therefore means that the quantity of nitrosol required to produce 100 liters of liquid soap will also increase. That brings us to the second topic that I introduced to you earlier, that is variation. That means that there is a direct relationship between quantity of produced soap and the quantity of nitrosol required. Just like I said earlier, this is where variation comes in. Variation can be direct, as we can see, between the quantity of liquid soap produced and the quantity of nitrosol required. Let's say these two variables are designated by x and y. Okay, this is where most of the time people lose their interest. When you start going very mathematical, they withdraw. Let's say these two variables are designated by x and y. For direct relationship, we say x is directly proportional to y. This means that if we want to convert this expression x is directly proportional to y into a mathematical equation, we say x is equal to ky, where k stands as constant or proportionality. Now as I proceed, I'm going to show you where k is going to come in. As we proceed, I'm going to show you how k comes in here. Now x therefore is equal to ky. Now I need you to pay attention to the k, which is a constant of proportionality, because I will show you in due course how to generate the k constant. Now for the inverse variation, let me just talk about the inverse variation, even though we're not going to use it here. For the inverse variation, we say x is inversely proportional to y, and it can be expressed mathematically as x is equal to k over y. In this relationship we're talking about, as one is increasing, the other one is decreasing. But in the relationship we're going to talk about with the nitrosol and quantity of water, x and y are in a direct relationship. Now we don't have any business with the inverse variation, just like I said earlier. From the explanation I made above, all our soap recipe variables have direct relationship with each other, which means if you increase one, then you need to increase the other. Now let's take an example from our typical video production of liquid soap, where we produce 15 liters of liquid soap with the following material, just like I said, with the following materials as shown on the screen. Okay, now let's start with the nitrosol. To produce 15 liters of liquid soap, we will require 50 grams of nitrosol. Now let's represent it as a ratio 15 to 50, just like I've demonstrated earlier. 15 is the quantity of liquid soap that we want to produce, while 50 grams is the quantity of nitrosol required. What if we want to produce 100 liters of liquid soap? Okay, remember the quantity of material given to us above can only produce 15 liters of liquid soap. Our question now is, what if you want to produce 100 liters of liquid soap? Now let's represent all these three variables in the ratio form. Now let's say this is 15 to 50, 15 to 50, okay, which means that to produce 15 liters of liquid soap, we will require 50 grams of nitrosol. Now let's call this one ratio A. Let's call this ratio A. Our question is that how much quantity of nitrosol is required to produce 100 liters of liquid soap? And that brings us to ratio B. From this expression, we'll have 100 ratio X, where X is the quantity of nitrosol that is required to produce 100 liters of liquid soap. Now, from this expression, ratio A is equal to ratio B. Ratio A is equal to ratio B. So let's bring the two equations together. Ratio A is equal to ratio B. So on the left hand side we have 15 ratio 50, which is equal to ratio A, equal to 100 ratio X, which is equal to ratio B, where X is the unknown quantity of nitrosol required to produce 100 liters of liquid soap. Let's move on. Now we say 15 ratio 50 is equal to 100 ratio X. Let's break it down. This is now pure mathematics. 15 over 50 is equal to 100 over X. Cross multiply. 15X is equal to 50 times 100. 15X is equal to 50 times 100. Divide both sides by 15. 15x over 15 is equal to 50 times 100 over 15. 15 will cross 15. You now have x is equal to 50 times 100 over 15. X therefore, now let's arrange the mathematics in this format, which is also the same. We'll say x therefore is equal to 50 times 100 over 15. I want you to take note of this 100 over 15. Please take note of this 100 over 15. Previously I talked about a constant called K. Okay, please take note of this 100 over 15. X therefore is equal to 333 grams of nitrosol. Now X, which is the unknown quantity of nitrosol required to produce 100 liters of liquid soap, is 333 grams. Is 333 grams from the calculations we've done above. So our unknown quantity of nitrosol required to produce 100 liters of liquid soap is 333 grams. 333 grams. Now you will repeat this process for all the chemicals needed to produce 100 liters of liquid soap. Take note, we are producing 100 liters of liquid soap, so we have to repeat this calculation for all the chemicals or ingredient required. Now let's calculate the quantity of caustic soda required to produce 100 liters of liquid soap. Remember, we have just calculated that of nitrosol in the calculations above. In the same way, to produce 15 liters of liquid soap, we will require 40 grams of caustic soda. Remember that to produce 15 liters of liquid soap, we will require 40 grams. To produce 15 liters of liquid soap, we require 40 grams. That of nitrosol is 50 grams. We require 50 grams to produce 15 liters of liquid soap, and we will require 40 grams of caustic soda to produce 15 liters of liquid soap. Now let's represent them in the ratio format. We will say 15 ratio 40. 15 ratio 40. Okay, and we'll call this ratio C. Now, to produce 100 liters of liquid soap, what quantity of caustic soda will we need? So let's represent it in the ratio format. We'll say 100 ratio Y. 100 ratio Y. Let's call this ratio D. Now, ratio C is equal to ratio D. So let's equate them together. We will now write 15 ratio 40 is equal to 100 ratio Y. Now, 15 over 40 is equal to 100 over Y. So, cross multiply. 15 times Y is equal to 40 times 100. Divide both sides by 15. 15Y over 15 is equal to 40 times 100 over 15. So Y, which is the unknown quantity of caustic soda required to produce 100 liters of liquid soap, is equal to 40 times 100 over 15. Just like I did earlier, take note of the 100 over 15. 100 over 15, okay, is 40 times 100 over 15. So Y is equal to 266 grams. If you multiply 40 by 100 divided by 15, you get 266 gram. Now 266 gram is the quantity of caustic soda you need to be able to produce 100 liters of liquid soap. Now in this calculation, you will notice that 100 over 15 will keep reoccurring. This is the constant of proportionality K, which I introduced to you earlier in the direct variation. Okay, the constant of proportionality is 100 over 15. Now that we know our constant of proportionality, which is 100 over 15, now to calculate other quantities like soda ash, STPP, SLS, etc., all we're going to do is shown as follows. Take for example, you want to calculate the quantity of soda ash, the quantity of soda ash required to produce 100 liters of liquid soap. All you're going to do is to multiply the 200 required to produce 15 liters of liquid soap by 100 over 15. Multiply 200, which is gotten from the figure of soda ash shown on your screen as the quantity of soda ash required to produce 15 liters of liquid soap. Multiply by 100 over 15, and then you get the quantity of soda ash required to produce 100 liters of liquid soap, which is 1333 grams. Now for STTP, you do the same thing. You pick this 60 here, and then you multiply it by 100 over 15, and then you get 400 grams. Now do the same thing for SLS, sulfonic acid, foaming booster, etc., to get the quantities of materials required to produce 100 liters of liquid soap. So this is all it takes for you to calculate the quantity of recipe required for you to produce certain quantity or volumes of liquid soap you want to produce. This calculation can also be done if you want to produce any other household product like disinfectant or any other cleaning agent. So thank you very much for watching, and God bless you. If you like this video, give us a thumbs up and subscribe to our YouTube channel. You can visit our website on www.sunshineresources.org.ng. You can visit our YouTube channel on youtube.com/c/Sunshine Resources SRTV. You can follow us on our Facebook page on Sunshine Resources. Thank you very much for watching, and God bless you.